Welcome back everyone to another Kuta worksheet tutorial. Today we're going to be taking on adding or subtracting fractions with different denominators. Really this should say and, right? It should be and. It's not like you're going to pick which ones you want to do. Anyway, so it says evaluate each expression. Let's go ahead and just start with number 1. So we have 3 over 4 plus 2 over 5, 3/4 plus 2/5. The most common mistake I see is this. Do not do this. Okay, again, this is bad. I'm going to write bad just so you don't think, oh, if you're watching this on mute or something, this is what you're supposed to do. 5 over 9. You add the top, add the bottom. That only works with multiplication. You can't do that. Now, why can't you add them when the denominators are different? That's because you're comparing two different things. That'd be like saying, okay, I need a different color here. Let's go with this. This looks close. So this is a penny. Okay, let's put a P for penny. And then let's get this. This is a dime. Okay, and then yeah, that's good. So then this is 1/10 of a dollar, right? And a penny is, to use this color, is 1/100th of a dollar. Okay, now let's say we had 2 pennies and a dime. Now, ignore the fractions for now. Let's move these down. Actually, no, we need the fractions. Let me get them back up there. Now, if we added these together and we used that improper procedure, we would call it, oh, I have 3, but then what would we call it? Would we call it 200/10? No, we're talking about out of a dollar. That's out of 1. So when we do it this way, what does that even mean? We are saying that all these are equal and they add up to some different part. No, these are not equal. The dimes are out of 10, or excuse me, the dimes are 1/10. They're 10 out of 100. The pennies are 1 out of 100. Okay, so we need to make sure that all these are first converted to have the same denominator. So what does that mean? Well, let me show you this example real quick. We first need to convert this dime to have a little bit more significance to us. So we know a dime is 10 cents out of a dollar, out of 100 total cents. So if we were to do this properly, we add, now that we have, okay, this is an important prerequisite, we have all the same denominator. We're going to add the tops and keep the base. So the base stays the same. This is huge. The base needs to stay the same. And then we just add the top, so it becomes 12. So this is 12 cents. As you would imagine, this is 12 cents, okay, or $0.12. Okay, so it's important that you have the same denominator. Otherwise, you're comparing unlike things. A dime is not the same thing as a penny, so you can't call it that. You can't just add the denominators together because it's not the same. You have to get them under the same understanding out of a dollar, okay? I'm going to keep this up there, but I'm going to shrink it, okay, because I need some more room. Okay, with this being said, the first thing we need to do is we need to convert these fractions to have the same denominators. This is the part nobody likes. Okay, some people might like it eventually. Hopefully they'll turn around, but most people do not like this. Okay, I like to stack them personally. And since they're both positive, I guess I can just put a positive there. And what I'm going to do is I'm going to put an equal sign for both of these. Now, we need to first decide what number goes here. What will be our denominator? Okay, now, we understood that with 1 and 10, or 110, that both those numbers went into 100, right? That was the common unit. But what's the common unit here? Well, in order to understand what both 4 and 5 could fit into, what we're really talking about is the least, let me write this down. We're talking about the least common denominator. Sorry. I really hate how people say least common denominator. It really should be the least common denominator, okay? So a common denominator means a denominator they have in common, and the least means it's the smallest one. So for example, you could put 100 for both of these. Both 4 and 5 go into 100, but there's a smaller number that they both fit into. How do we do that? Well, if you're very new to this, you could list the factors of 4. So 4, 8, 12, 16, 20, 24, so on, okay? And you could list the factors of, or excuse me, the multiples of 5. So we could list 5, 10, 15, 20, 25, 30. Okay, so these are the possible multiples of 4 and 5. Okay, now we're talking about a common denominator. What do they have in common? Well, 4 and 5, no. 4 goes into 8, but 5 does not go into 8. Okay, 12, 4 goes into 12, but 5 doesn't. 5 goes into 15, but you get my point, okay? There's not a lot, so you look for a common number, and that's 20. And that's the smallest number that both 4 and 5 go into. Oftentimes, the easiest way to find the common denominator is to multiply the two denominators. Now, that's not always true, okay? And there's probably future videos I'll make on that. But it will always work, but it might not be the least common denominator. It will always be a common denominator, but might not always be the least. So we're going to go ahead and put 20 there. Let me make it blue. So make blue, 20, 20. Now, the second part is, how do we go from 5 to 20? Well, to go from, oops, sorry, I didn't want to jump ahead there. To go from 5 to 20, we had to multiply it by 4. And what you do to the bottom, you also have to do to the top. So we're going to put times 4 there. Okay? Once we do 2 times 4, I'll just write 2 times 4 for now. Now let's look at the top. How do you go from 4 to 20? Well, you multiply by 5. 4 times 5 equals 20. What you do to the bottom, you got to do the top, times 5. And we get 50. Oops, sorry. I meant to put 3 times 5. Oh, my goodness. Disaster. Here we go. 3 times 5. Okay, so now I'm going to move this. Boy, I'm just using so much space. So now I have 15 over 20 plus 8 over 20. So now I can add these together, and what do I get? I get 23 out of 20. This cannot be reduced. Okay, if these fractions can't be reduced, then that one can't be reduced. So we have 23 out of 20, and that's our answer. Let me do a couple more. I'll try to do it a little bit quicker. I think I'm running short on time. Okay, let's take on number 5. This one's got a 1 in it. So number 5, we don't have a common denominator, but this one's pretty easy. How to convert 1 to have the same denominator as 7? Well, you can always put over 1. For any whole number, you can put it over 1, and it doesn't change the value, because it's just 1 divided by 1 is 1. 2 divided by 1 is 2, okay? So it doesn't change the value if you divide by 1. So how do you go from 1 to 7? Well, this one's fairly simple. 1 over 1, 3 over 7. What's their common denominator? Well, with 1, 1 is a multiple of every number. So we can just, let's write this like this. Let's do this properly. So we can just use 7. Why? Well, 7 times 1 gives us 7. 1 times 7 gives us 7, so we're going to multiply by 7. Sorry, multiply by 1. So we get 3, 7. Okay, so 7 over 7 is the same thing as 1. Now we do 7 over 7 plus 3 over 7, and we get 10 over 7, and that's our answer. Okay, so fairly simple with a whole number. That same principle is going to apply here. You put it over 1, and then you're going to see that is pretty easy with that one. Let's do, I guess let's do number 13. So number 13, we have 2 over 3 and 10 over 7. So 2 over 3, 10 over 7. We need to have a common denominator. What's that going to be? 3 and 7 both go into, the smallest one is actually their multiple. So 3 times 7 will give us 21. So we need to figure out, this is times 3, so we have to do the top times 3, and that's 30. We have to do this times 7, so the top has to be times 7, and that's 14. And this was adding. I should have done a subtraction one. All right, I'm going to do one more, and if you're done, you get it, go ahead and leave. But I just want to do one more just so those that need to see subtraction can see it. So this is 44 out of 21, final answer. Okay. All right, there is a subtraction. Oh, okay, there's one. So we have a whole number subtraction. There we go. I think that's the one I'm going to want to do. Okay, so let's do this whole let's do number 4 actually. So we have 5 out of 8 Okay, and then negative 1 over 7. Now you're like, whoa, I thought it was subtracting a positive 1 over 7. If you combine these two, I like saying combine versus add, subtract. 5 over 8 plus a negative 1 over 7, it's the same thing as subtraction. Okay, principle still applies. We're going to try to find a common denominator. And I don't think 8 and 7 have a common denominator that is lower than 56. Because 8 times 7 gives us 56. I don't think there's anything smaller. Okay, so we're going to roll with 56. 56. Okay, so I'm going to do this quickly in my head. Hopefully you guys see what I'm doing here. So we did 7 times 8 gives us 56. So we have to do the top times 8 also. So we get 8. Don't forget the negative sign. That stays with it. Then we did times 7 here. So we did times 7 at the top, 35. And now we change it to 35 over 56 minus 8 over 56 equals, well, what does it equal? Well, 35 minus 8 is 27 over 56. Can't be reduced. No, it can't. So we're good to go. Hopefully you found this helpful. Good luck with all your fractions. A lot of people don't like it. If you're struggling with this, just know that you're with 75% of the world or more that have a hard time with fractions. And I'll see you next time on Wes Explains Best.